All right, here we are, and we're going to take a look at the next example, 2. And in order to do that, we need a new rule, quotient rule. Why do we need this? Well, what if you have a function like this? Sine of x over, let's say, maybe the cotangent of x. In fact, let's not even use that. Let's try, because you might say, oh, I can simplify that. Let's try if you had the sine of x over the tangent of x. Okay, which I guess is just sine of x times cosine of x over sine x. So that's really not a good example. How about the sine of x over 3x plus 2? What can you do with that? Well, without the quotient rule, nothing. Okay, without the quotient rule at this point, you can't do anything with it. So it'd be hard to differentiate that. So that's where we have this new rule. F and g have to be differentiable, and g not equal to 0. Now the proof of this is in the textbook. We're not going to go through that proof. You can read through it. It's interesting how it's developed. I'm going to focus on how to use it. Okay, that's what you really want to be able to do from this course, is use these rules. You can learn to appreciate the mathematics possibly as you move down the road, but right now I just need to get you to be able to perform these mechanical procedures, finding derivatives. And then that way you can use it as a tool for analysis. Later on, you might go back and dissect some of these theorems. They're interesting in their own right. Okay, so this is our rule. Now, I tell students to remember this, to say this to yourselves. Anytime you write it down, read it to yourself. It's the derivative of numerator times the denominator minus derivative of denominator times numerator, all divided by denominator squared. So that's what you should remember. Okay, I would suggest, because if you come and look at this and say, oh, f over g, that's f prime g, g prime f over g squared. What if I give you g over f? Then if you remember these symbols in this order, then you're messed up. What if I give you h over g, for example? How would you differentiate that? Well, you have to remember derivative of the numerator. So if you had it, you're trying to find this, you would say, oh, that's h prime g minus derivative of the numerator times the denominator minus derivative of the denominator times the numerator, all divided by denominator squared. So that's how you should remember it. That'll help, I think. Okay, let's go ahead and work some problems here. This is going to take a little bit. Let's try to get through it quickly. You can always go back and pause the videos and look at it again. So, all right, so we see we got a quotient. We're going to start right off. Derivative of the numerator is a 1 times the denominator minus derivative of the denominator, which is a 1 times the numerator, all over the denominator squared. And then you probably would want to simplify this. This would be x plus 1 minus x plus 2 over the x plus 1 squared, which is just a 3 over the x plus 1 quantity squared. And you can leave it like that. Next one. Well, the secant of x, that is 1 over the cosine. So if we want a derivative of the numerator, which is a 0, times the denominator, minus derivative of the denominator, which is a minus sign, times the numerator, all divided by the denominator squared. So we have a sine of x over cosine squared of x. Now, there's a couple ways you can write that. You can write this as sine of x over cosine of x times 1 over cosine of x. And typically, this will be written as the secant tangent. And that's pretty much how most students remember. The derivative of the secant function is the secant tangent. Okay, interesting result. So let's continue the next one. Okay, we handled this before by treating it as a product of x to the negative 1 with sine of x. But now we can just jump right in and treat it as a quotient. So g prime would be derivative of the numerator times the denominator minus derivative of the denominator times the numerator, all divided by denominator squared. So that's x cosine x minus sine x over x squared. That's the same result we got before. Okay, tangent. Well, we don't have a formula for the tangent yet. We will in a minute. First of all, write it as the sine of x over cosine of x. Okay. Now we'll use our quotient rule. So derivative of the sine, numerator, is cosine times the denominator, so cosine, minus derivative of the denominator, which is a minus sine, times the numerator, which is a sine, all divided by denominator squared. Well, that's a cosine squared plus a sine squared over cosine squared. Well, that's 1 over cosine squared, and that's better known as the secant squared. So what we see here is a derivative of a tangent function is a secant squared, and that's the result you want to remember. Because so far we've got 4 of the trig functions done. We've got sine, cosine, secant, and tangent. We know how to differentiate those. Okay, and this will round out that sequence, that series of functions now. So let's go ahead and treat this one as 1 over the sine of x. Derivative would be derivative of the numerator times the denominator minus the derivative of the denominator times the numerator, all over the denominator squared. Well, that's just cosine of x over sine of x times 1 over sine of x. That is a cotangent x times a cosecant x. And many times this is just remembered as the cosecant x, cotangent x, although the order doesn't matter for those factors. That's how we remember the derivative of the cosecant, cotangent. Okay, now we have another one here, it's cotangent. Now there's a couple ways we can do this now since we already know the derivative of the tangent. You could say, okay, f of theta is 1 over the tangent. And then start right in, f prime of theta, derivative of the numerator times the denominator minus derivative of the denominator. Now, we did that tangent one, didn't we? Or not? Yeah, we did it. It's right there. It's right in front of me. Okay. The derivative of the tangent would be a secant squared times the numerator all over denominator squared. And this is a theta, sorry. Okay, so that is just secant squared minus secant squared over the tangent squared theta. Now, we could probably get this down to something a little nicer. Let's get it in sines and cosines. So you can cotangent. Let's get it in sines and cosines, maybe. It's a little nicer. Okay, so this is minus 1 over the cosine squared theta times cosine squared theta over sine squared theta. And that is, notice we get that cancellation there. We have minus 1 over sine squared, which is minus the cosecant squared theta. So there's our result. Derivative of the cotangent is minus cosecant squared. Okay, now just a little note here. Let's see. In fact, let's call it quits at that point. That's enough for one example. So let's